Solve the quadratic equation and show all of your work. So, how do we solve this? Remember, you can always solve using the quadratic formula, which you have to have memorized. Not every quadratic equation will be factorable. Let's check if this is factorable, because generally that's a faster method for most students. 3 times negative 8 is negative 24. Can we think of two numbers that multiply to give you negative 24, combine to give you 10? So 1 and 24 don't work. 2 and 12. 2 and 12 do work if 12 is positive and 2 is negative. They multiply to give you negative 24, and they combine to give you a positive 10. So we have x subtract 2 and x plus 12. Remember that whenever the leading coefficient is different than 1, we have to do a bottoms here. This does not reduce. This does reduce to 4. Now it's a habit of most students to push this up, to do bottoms up. We're not rewriting this in factored form. We're looking for the answer. So one answer is x equals 2/3, and the other answer is x equals negative 4. Opposite signs. Turn the page and look right now at number 7. So number 7, you ask yourself, is this factorable? Checking that, is this factorable? Remember, if you don't want to use factoring or checking that, you can always use the quadratic formula for every problem. So this multiplies to give you a negative 24. The numbers that multiply to give you negative 24 combinations, but combine to give you 5. 1 and 24, no. 2 and 12, no. 3 and 8 do work if the 8 is positive and the 3 is negative. So it's going to be x minus 3 is x plus 8. Because the number up front is different than 1, we have to do the bottoms. Now reduce those fractions. And we don't have to push up the 4 or the 3 because we're not ready in factored form. We're solving. One answer is x equals 1/4. The other answer is x equals negative 2/3. Number 8. So we're looking right now at number 8. And we're going to ask ourselves, solving this quadratic formula, can we think of a combination that multiplies to give you 40 and adds to give you 6? 1 and 40 do not work. 2 and 20 do not work. 4 and 10, a lot of students are going to say, hey, this works if 10 is positive and 4 is negative, and that does work to give you a positive 6, but they don't multiply to give you a positive 40. And so as far as I know here, there's no combination that works here. Even 5 and 8 don't work. So when we can't find a combination that multiplies and combines, we're going to revert to the quadratic formula. So we need to show our work, which I'm doing right now. Then I find the A's, the B's, and the C's. And then I'll let the calculator do the majority of the work for me. So I'm going to figure out the discriminant right now. I'm going to plug it in just like I see it. So I see 6 squared minus 4 times 8 times 5. 6 squared minus 4 times 8 times 5. So I get a negative 124. Ew, that's ugly. Negative 124 inside. And you know we can't take the square root of a negative. Well, let's figure out what is the largest perfect square that goes into 124. So let's start with some of the perfect squares we know. We're going to work from the top down. So let's divide by 36. That does not divide nicely. I know 25 doesn't work, but I'll show you. Let's try 16. 16 doesn't work. And I know 9 doesn't work, but we'll show you. That doesn't work. And let's try 4. 4 works. 4 times 31. The negative comes up front and becomes an I. 4 times 31 is 124. And now we are continuing to reduce this. So this is a complex number. It has an I, and that's because the discriminant in the discriminant of the radical or the square root was negative. That's what led to this becoming a complex number. Square root of 4 is 2. And now you have to ask yourself, does 16 reduce with both of these numbers? It does. So let's start with this one. I'm going to do x equals negative 6 over 16 and 2y radical 31 over 16. And we continue to reduce, both even, divide by 2 and divide by 2. And both even, I'm going to divide by 2 and divide by 2. Number 9. So solving this, what can we do here? Well, two different ways to solve this. Notice that we don't have a b value. There's no x. So some students choose to factor and solve, and some students choose the algebra method. Algebra says I'm going to move this deficit aside by adding. Then I'm going to divide by 49. To eliminate the square, I'm going to square root both sides. Notice that I'm going to have two answers. Square root of 100 is 10. Square root of 49 is 7. X equals plus or minus 10 over 7. In question number 10, you're asked to identify which problems produce complex numbers. So look at your answers for 6, 7, 8, and 9. Only one of them has an I answer, which is number 8. And now explain what led to this being a complex number. And the reason it became a complex number was because the discriminant was a negative. And you can't take the square root of a negative number, which then leads to us taking out the negative and it becoming an I.